It's John Black, super chemist. This is how to make benzyl chloride. Now, if you want to make absolutely 100%, 1,000% sure that you only have benzyl chloride, okay, and you have no other chlorines on there, okay. Now, first of all, if you're doing this and you're going to hydrolyze this stuff, it really doesn't matter, because if you hydrolyze it, you can easily get this impurities out of here. If you don't hydrolyze it, and you say you want benzyl chloride for a Grignard reaction, okay, now it matters. You don't want to have any impurities, you know what I mean? If you want zero impurities, this is what you do. You hydrolyze it, right, with sodium carbonate, sodium bicarbonate, sodium hydroxide. This is probably the best, though. Sodium carbonate is probably the best, but this is second best, and it is the easiest thing to get because it comes right from the store, baking soda. Now, benzyl chloride is a lacrimator, okay? I'm not sure I'm saying that right, but basically that means it's a tear gas, okay? Gets in your eyes, and it will hydrolyze to benzyl alcohol and HCl. The HCl will burn your eyes, and that's why it is called a lacrimator. Now, my whole point on why I'm bringing that up is because of this. You don't heat your eyes up, okay? If it gets on your sweat or it gets in your eyes, it just automatically, I don't know, probably not all of it, but some of it turns into HCl and benzyl alcohol. My point is, that's how easy it is to hydrolyze a benzyl chlorine. Now, to do this reaction, because basically you're getting an OH, the OH negative is going to come up and do an SN and kick off the chloride, and the OH will be on there to have benzyl alcohol. Okay, it's tough to do an SN with OH because it's a base. It likes to do base stuff. It likes to take protons off and be a base. It doesn't like to be a nucleophile as much as it likes to be a base. So anyways, that's my point, is that it's easy to do it even without heat. It automatically happens. Although if you want it to go to completion, you know, you're going to heat it up. Now, once you do that, okay, any impurity, the benzodichloride or the benzyl trichloride, will also be hydrolyzed. Okay, this will be hydrolyzed to benzaldehyde, right? Now you have benzaldehyde and you have benzyl alcohol. How do you get rid of, and you want the benzyl alcohol to be pure. So you want to get rid of the benzaldehyde, you do a sodium bisulfite adduct, and that will turn this benzaldehyde into a solid, and you can filter it out. Now you have pure, you know, you have a benzyl alcohol pure. And if there's this is in there, it'll turn into benzoic acid. Well, sodium benzoate, which is a solid, which can easily, again, be taken out of your product. So now you got rid of all the dyes and trichlorinated benzene, benzyl products, right? And then you just do an easy HCl plus stannous chloride, tin chloride, and you heat it up a little bit. Like I said, this is a benzyl position. That's better than primary, better than secondary, better than tertiary, okay? So this, again, is a very easy reaction. It wants to go to completion, and you would end up with benzyl chloride again, what you started with. But the only difference is you took out all the other, you know, the dichloro and the trichloro derivatives, and now you definitely have benzyl chloride that is pure of any other benzyl chloro derivatives. You know what I mean? Meaning these two things. Then you got super pure. Another thing I wanted to bring up about this is if you're using benzyl chloride for a Grignard reaction, it is actually better than benzyl bromide. Benzyl bromide is a terrible compound to use for Grignard reactions. They're a lot easier because it's so big, the bromine, and being on a benzyl position, you can actually make benzyl bromide with an incandescent light bulb. That's one of them light bulbs they had 5 or 10 years ago that basically look like this. Right, that light bulb type right there. You could do a halogenation of toluene with bromine just using that, believe it or not. Okay, that's how easy it is to, you don't even have to heat it. You could just set some toluene and some bromine out in the sun and go back, you know, a couple hours later and it'll be done. No heat, no nothing. But if you're doing it for a Grignard reaction, I'd go with the benzyl chloride. You'll have definite problems with this. Now, we discussed what I would do if I was making benzyl chloride. I would do a 40%, at most 45% chlorination of the toluene. I'd recycle the 54% of toluene that didn't make it, and I wouldn't have to worry about any impurities really. If I want to do it for a Grignard reaction, where I want it to be perfect, I'm not going to hydrolyze anything. I would still probably hydrolyze it so I can make benzyl alcohol and then do my benzyl chloride. Okay, that's really the only way you're going to have 100% pure benzyl chloride. Okay, you're always going to have some little tiny trace amounts of impurity if you do it stop here. So next we will go into how to make benzyl dichloride and benzyl trichloride. Now, if you want benzyl alcohol, you want the benzyl chloride. If you want benzaldehyde, you want the benzyl dichloride. If you want sodium benzoate or benzoic acid, then you want the benzyl trichloride. Right, if I was going to make benzyl dichloride, some people call it BENZAL chloride, I would go with a 93%. Instead of 40 to 45% trying to put in chlorine compared to 1 mole of the toluene, I would put in 93%. Why? And that's why I chose these numbers and that, because this is 93%. If I do a 93% thing, I'll get 35% my product. And after that, see, once you start doing that, you're going to start making the trichloro. As much as you make this, oxidize this into this will be made. You know what I mean? Every molecule you make to make your dichloro derivative, you'll make a trichloro. So it's like it defeats the purpose after that. Okay, so you need to stop. All right, or at least that's what I'm going to do. So I'd put 93% of a mole of chlorine in, 1 mole of toluene, and this is what I'd get. Now, that's not much, right? But this you can easily, you can see there's a big boiling point difference. You can get that out and reuse it. So that's no big deal, right? There's barely anything in there. You know what I mean? I'm actually going to do a little bit less, so I get 33% here, and hopefully, or 30%, and hopefully nothing here. But it's almost nothing, so that's no big deal. This is the big deal. You have a lot of benzyl chloride. I'm going, because I really don't, there's no use for these two things except to, I don't know any other uses except to make benzaldehyde and make benzoic acid. This has a million uses. So all I want to do is make benzaldehyde with it. So I'm going to do the, if you're not doing that and you just want to isolate this, you're just going to have to, the boiling point is so close together. I really don't know what to tell you about separating that and getting this pure. But the video, these videos are about basically making this and making this so I can make benzaldehyde. So what I'm going to do is I'm going to do this. I can do the hydrolyze it right, with baking soda, and then I'll have 55%, of that. It'll be the benzyl alcohol, and this will be my benzaldehyde. I can easily get the benzaldehyde out by a bisulfite adduct, turn it into a solid, filter it out, and now it's pure, right? And you might say, well, you only got a 35% yield. That sucks. Yes, it does, but I have the benzyl alcohol, okay? Now, I could either take that benzyl alcohol and just, oxidize it up to benzaldehyde, which is fairly easy. Or if I need the benzyl alcohol to do experiments, I can use it for that. So either way, say I get 30% here, and then this one, I get 50%, but then by the time I turn it into benzaldehyde, it's 25%. So I get like maybe a 55-60% yield overall once I get done, turning this into benzaldehyde. And you're making the benzyl chloride. You know what I mean? Like you can see here, the only impurity really is going to be the toluene. And look at the boiling point. It's like 70-degree difference between these two. You can easily distill this benzyl chloride out and leave this in the flask. But see how it kind of has a close boiling point. It's only like 25 degrees apart. But you have such a small impurity. My point is that this stuff is nasty. You know what I mean? You're going to have to distill it. You're going to have to dry it. You're going to be opening and closing the flask a lot. You definitely need a fume hood no matter what in any one of these experiments. But my point is to make benzaldehyde from the benzyl dichloride, you can make this, right? You're refluxing it. You're done adding the chlorine. Basically, as soon as you open the pot, you know what I mean, you can add this sodium bicarbonate, you know what I mean, to do your hydrolysis, and hurry up and put a condenser on top, you know what I mean, and start condensing so none of the fumes come out. Now you don't, you know what I mean, that's the only time you'll have to really smell it. You can just throw your toluene in there with it, with the hydrolysis thing, and get it out after, you know what I mean. Now you hydrolyze everything, right? Now you have benzyl alcohol, benzaldehyde. Benzaldehyde supposedly smells good, even though it's probably bad for you. All chemicals assume are bad for you. So you have these two. I don't think benzyl alcohol is like some nasty smelling, where it's, although it's probably not healthy. And what else would you have? You'd have your toluene, another thing that isn't nasty. But again, isn't good to breathe. The whole point, though, is that by doing the hydrolysis, when you're going straight for benzaldehyde, or if you're going for benzyl alcohol, you know what I mean, you would not have to deal with these nasty, like this is a lacrimator. I'm sure these are all lacrimators, but you won't have to be breathing them as much. You won't have to be, in contact with them as much. So that's at least one good point about doing a hydrolysis. Now, if you need benzyl chloride and you need it really super duper pure, you're going to hydrolyze it again. You're going to hydrolyze this too, so you at least get rid of some of the nastiness and be left with, until you get up to this point and get the benzyl chloride back. Now, for the the benzyl trichloride, that one's an easy one because you just put in 3 moles, a little bit over 3 moles of chlorine and 1 mole of toluene, and you just let it react. Now, the thing about this reaction is because you're making free radicals, they are really extra reactive. As soon as you make them, they want to do something. They're